The topic of this speech will be about XML, one of our buzzwords for the last years for classic data. First, I have to apologize because I totally screwed up my notes, my slides, my whatever. I sent them over, they didn't come the right way. No, I have nothing to print out. So what I did was just on a fast way get the definitions out again, and I'll have to do it just by talking. The whole thing started out about 2 years ago on a classic computer mailing list. It was again a discussion about how to transfer data from old machines into modern storage areas, or how to preserve data at all. There's a lot of standards coming up, or a lot of ways coming up, and everybody who tried to preserve data did it its own way. Some guys started out taking the same classic machines as they want to preserve, tried to get new tapes, new disks, new whatever, and just copied over. Others are going for emulation standards. Very prominent is all these stuff around Apple IIs, Apple II disk formats, or C64 disk formats. A real problem in there is every of these standards is separate. Every of these standards is just for one machine, one purpose, and as soon as the machine standard changes, the tools changes, or whatever changes, the data is as worthless as it has been before. So in the early 2000s, we came up with the idea of using XML as metadata to describe the data of the classic machines we want to store. We were going up from 10 basic ideas such a format has to support. Here we go. This is taken out of this said mailing list discussion. I formulated it back then. The first and most important thing is whatever format. Can you capture it on the screen?
Yeah, I can get your notes afterwards too. Oh, I can get that.
Whatever format we're coming up, it must be able to really support any kind of storage media. Not just copies of Apple GCR coded disks or Commodore whatever disks or PC disks or DEC paper tapes or whatever. It must be able to support anything in there and any data format one could think of, starting from floppy disks and ending up in cassette tapes, paper tapes, etc. Of course, it should be an abstract view on the data. Not like how the magnetic fields are on a GCR disk or how the holes in the punch tape are ordered or whatever, because this got no meaning if we talk about the data. It may have special meaning if you talk about the hardware, but not if you talk about the data. The next thing is, of course, we should be able to add physical definitions. If we're coming back to the Apple, I don't know how many of you have worked with Apple. At least in the early 80s, there was a ton of copy protection schemes using half tracks, quarter tracks, inverted bits, and whatever they came up. So if we want to preserve software like this, we have to have a way for special cases to go on the physical level. So a format should support like this. The next is, of course, hardware independent and expandable. Well, there's 2 points in here, but hardware independent means I should be able to take it out and put it on a completely different machine. So anything which is a physical representation is out of discussion in here. We need something we can transform, which is basically readable data. ASCII. Expandable. Of course, if we sit together and think about the machines we know, there will always another machine come up with a total weird, different format, total weird, different structure of data, and we need a format to support even this. The next one is totally clear because we want to keep it over a long time available, so we have to be able to transport between the machines. It should be able to recover from errors if we make it robust. This is meant as an add-on. Next thing is, which is a variation of being expandable, so we could transform in other definitions. I'm sorry, I'm not a native English speaker, so sometimes my tongue gets wasted up. Which means not only transferring between machines and expanding to other formats, but rather also transferring between different formats of emulation data, storage data. For example, if we have an Apple II emulator running what kind of Apple disk image format, it should be able to take this image and put it into the general format, or put images from the general format into the disk image of this specific emulator. The next one is very clear. If we're talking about classic hardware, we can't come up with any kind of sophisticated scheme where we need, I don't know, 2 billion floating points per second DSP processor to handle it. It must be as simple as it can be, that a single portal like a KIN can do it. And last but not least, we should be able to have more than one data in one data transmission. Why? I can't always have single data files pulled over. I need sometimes archives to get data which belongs together in one chunk transported. The solution of that was coming up with a 3-level format. A level 1 to describe basically the logic content of the media. A level 2 to describe possibly physical encodings. And a level 3, and this might surprise some people, a definition of a storage landscape. Because if you want to preserve a specific setup, it's not just that you have to describe the content of the disk. Sometimes you have to describe how these disks are organized. For example, I'm originated in an IBM landscape, or IBM-like landscape, based on the 370 family. If you have programs in there, they expect disks to be at specific addresses. They expect specific data tapes in specific drives, and so on. If you want to run really an application out of such data, you need to store even the environment, the configuration. Yeah? Each of these 3 levels are meant to be independent of each other and meant to work separately. So a format, according to the upper 10 points, should be also able to just describe a storage landscape, and the data is separate. Or just describe the data so I can have the storage landscape somewhere separate. Okay, for the next one, could you please switch on the light again? Because now I have to go for the how do you call these things? Whiteboards. Just to point this out. Called the flip chart. Flip chart? Okay, that's the way we use it also over Germany, whiteboard, flip chart, whatever. If there are any questions about what I'm talking, just go ahead and ask me, please. Because I'm just going on and on. I want you to follow, or I want you to get at least an idea what I'm talking about. I'm not very experienced as a speaker. We were talking about the landscape and to put things apart. One thing is to have one big description, yeah, where I have maybe the landscape defined here, and then the data chunks here, and links in between the data and the landscape. Yeah? Having, that's good to tell you. I should have started with a question. Who of you know about XML and who doesn't? I was just automatically assuming everybody of you is familiar with XML. You're not familiar with XML? I'm sorry.
Okay.
I'm sorry. I'm really sorry. XML, as I started out, it has been a buzzword for the last 2 or 3 years. XML itself is basically nothing. XML just tells you how to format tag information. It just tells you if you want to format information in an XML way, you have to use start and end tags to describe the information. Like if you ever see HTML, you go ahead and say H1 for a header, and then you say H1. This is a perfect piece of HTML and a perfect piece of XML. This is a chunk of information covered in a tag. Start tag telling you what kind of information is following, and the end tag telling you that's the end of the information. Always enclosed in the, how you call them?
Angle brackets.
Angle brackets, okay. This is the whole trick of XML. There is no definition in XML what is content in, what's about, and whatever. It just says structure your information using tags in this, sorry, in these kinds of brackets, and that's it. So an HTML document, for example, is just made up of this basic XML idea, how to format text, and then these tags, tagging the information, put information about the information, what it is, and then an interpreter can go along and say, oh yeah, now I found a header, I got to take a larger scale font, a bold font, or whatever. Or now I have a new paragraph, put up a new line, or whatever. This is not what to do with this information, is not in the format. The format is just about how to write it down. So this is exactly the same like if you had a data format, say start with a chunk type 01, all hexadecimal, 01, and then a length of 06, and then having something like this, it's exactly the same as XML. XML itself is not a new idea, it's not something special, and it's especially not something out of heaven or hell. It's just another way to tag your information. Excuse me.
Sounds like the big problem is getting everybody to agree on what the tags mean.
Well, this is not a problem of XML, it's a problem of the usage of XML. Yeah? The usage is always the next level. The basic idea of XML is just standardization of tagged formats. You know, like you have standards on your imperial system for doing screws, doing whatever, the gain of a screw, stuff like this. This is standardized in your system. It's like in the metric system. There are several standards, how bolts are done, and so on. The idea about these standards is not this is the perfect solution. The idea is just having one solution and use it all over, and then you get the benefit because you can reuse the tools. As soon as you have standardized that the head of a bolt is a six-sided shape, you can go ahead and make tools wrenching the bolt without knowing who manufactured the bolt, what the bolt is holding up, or whatever. In the old times when we didn't have standard like this, every company was coming up with their own kind of bolts. Every company was coming up with their own kind of tools, and so on. Does this sound like software?
Yeah.
It sounds exactly what we did for the last 20 or 50 years. Every company was coming up with their own standards for things to do. Yeah? So XML is an idea to tag information in a standardized way. And like a bolt, a standardized bolt doesn't tell you for what is to be used. It can be used in a car, in a computer, in a ship, in whatever. The bolt doesn't tell you. So XML doesn't tell you what the tags are for. It just tells you how they're basically to be handled. Any other questions, XML?
What happens if you want to have a tag that nobody else uses? You say, I need a different tag.
you cannot come up with tags whatever you want. Yeah.
That works.
You're going ahead and do a format of your own. If you want to define for a program of your own syntax of a storage file, you go ahead and define the tags you need. Yeah. Then you can use a set of standard tools like a parser to parse through there to find your tags. You don't have to write your own parser. As soon as we come to a meaning of a tag, yeah, you have to agree with other users what's the meaning, but not what's the formatting of the tag. Tag always starts with a brace like this and closes like this, and the end was always a slash like this to denote the end. Yeah. What's the meaning? The meaning in here in the HTML file is header level 1. This is a definition of HTML. It's not a definition of the underlying XML. And this is just an agreement between all browsers and HTML page editors to say, okay, this is a header. They could have come up with something completely different.
How is this any different from, like, say, comma delimited files? Where
It's
like comma delimited files in the old days, if you wanted to export
well,
something?
in fact, the comma delimited, what a word. A comma delimited, the kind of file you're talking about.
That's right.
This is also just a convention to come up. Yeah. The problem is, if you just have data items separated by commas, which it is, you have really no idea how to parse it. Yeah.
But you still have to know what, like here, you have to know what the tags mean, right? Yeah. Where in the other case, you just need to know what the file format is.
Well, this is the same. This is a file format. And you
comment-
have to know less on this.
The primary difference is that in XML file, there is a hierarchy of the tags, at least potentially. So there's a little bit more structuring than just comma delimiting. But fundamentally, yes, but either format you can shove arbitrary data into, and that's both the strength of it as well as being a slight weakness in just the fact that it's XML doesn't tell you what the content means. You have to know what the tags are for that.
You always have to know the content. Just in XML, you can have a structure which can be parsed by tools which you don't have to build because you can use standard tools. In a comma delimited, in the file we're talking about, you also have a structure because you have two structure elements. You have the structure element new line, which says this is a new record, and you have the structure next element. Yeah, you can have exactly the same. We were talking about A, B, C, new line, right? This is your file. Now we can do the same in XML if we said we define a format named CSV is our format. This format got the next level called record, and then the next level called data. Having one element A, an element B, and an element C. When we say end record and end of our file. This and this is from the structure exactly the same. You have a file itself. This tag denotes the file. You have a record to say this is one record. And you have data elements in the record. Data, data, data. Yeah? So up here, we have nothing gained. Just we could use now different kind of information here. We could, for example, say, okay, we stay with the generic comma-separated file type. Now, we can go ahead and put in here additional information. Like we could say the data element may have some attributes like type equals. We could say here for what's that called? Zip, or type equals street, or type equals town. Now, if we add this attribute in here, we could put the external knowledge, which is in this file, totally external, in the file, and say, okay, this is a data describing a zip code. This is a data describing a street. This is a data describing a town name. And from there, you can extend the whole thing. And like you have data structures in a programming language, you can have exactly the same structures in an XML file. I think that's one of the best equivalences to take here. Take basic programming language, basic array. You just have array A with 10 elements, and you have A1 until A10. This is A1 until A3. And here we have a structure of a language like Pascal, where you have in one bracket the element town, the element street, the element zip. I guess we all agree it's a little bit easier to program and to think along if you have real data structures instead of just values in an array. I think we should stop this here unless there are more questions and go back to our topic for classic data. Now, when someone comes up with an XML structure, yeah. Wait a moment. Okay, let's go take it. When someone comes up with an XML structure, he has to come up with a definition to describe the structure. Okay. You only have 4 ways to put up the sheet. This is like the definition of a programming language structure you use in any kind of programming language. Like in Pascal, where you say record, and field, and so on, or COBOL, or whatever. Thank you. This is the document type definition for an XML file. It just tells how the tags we're using are defined and which tag can reside within which other tag. For example, no laser pointer, just old-fashioned technology. This is classic computing. This is not 21st century. For example, we have for example, a channel tag, which can include none or one meta tag and one or more device tags. Or we have a block tag, which can include a raw tag or a data tag. Whatever these tags are by now. This is just a description of the structure coming down. You don't have to write this for each of your programs, because this structure is basically defining the standard for doing this kind of XML, doing one XML file for classic data. The topmost element is CCDD, and this is the name of the whole project, Classic Computer Disk Dump. Because we started out from doing a disk dump on a regular computer and tried to store this disk dump. Now, I made up here some examples how this could work. First one, let's see if I get it on here. First one is, yep, I have it on here. Again, 4 ways, not more. Okay. So what we have is we have a file type CCDD, this is the topmost tag starting the file. So if you get a data file and look the first tag, if you look into an HTML file, you will find the first tag being HTML, denoting the type of the file. If we look into one of the classic data files, we'll find as first one CCDD, because this is the name of the structure we just defined. The next thing we have in here is a meta description. I don't know how many of you have worked with classic IBM tape files. Oh, great. More than I thought. Because what we have in here is a description of an IBM-like tape file. Okay, it's not taken from an IBM operating system, but rather from a Siemens operating system, BS2000. But the tape files are using the same header structures as used in IBM tape files. So basically, we're going ahead, having a meta which has some kind of meta information. You could put in whatever you will. It's just a description block. And then it comes up with a channel description. It describes a channel where this tape is hooked to. We have a channel called C1, whatever this means. In this channel, we just say, okay, it's a type 1 channel. In this channel is one tape drive called D_0. Again, a description of the tape drive. Doesn't matter in here, it's just a description for reading. The program would just go ahead and say, okay, I have to build up a structure with one channel and one tape drive on the channel. And then on this tape drive, now we come to the data, is one media mounted. The media gets just an ID called LFD here for, well, this is a German term, laufende Nummer. Of course, the term ID is reserved in XML for special purpose, so I had to come up with something else. And the format tag, it says just this ID 0 and T6250 describes a type tape with 6250 bytes per inch. It was bytes per inch, wasn't it?
Yeah.
So again, a media which just tells anything, and then the tape starts. Here we have a head. The head describes the reading head on the media. For a disk drive, you could have several heads. For a tape drive, of course, you will have only one head in there. The first head got the size of 36. Wait a moment. Yeah, got a first size of 36 bytes, and it's just filled up with zeros. Then we come up, get the first track. In the track is a block, a header block, size of 80 bytes, encoded as characters, fillers of space, and this is the data encoded in here. The one of you who know IBM files see it's a volume 1 label. We just come up with the next block. It's a user volume 1 label, encoded as above. Then we get header 1, which denotes the file name, which is file 1 in this case. A header 2, additional header 2 information. Header 3, I tried to just come up with as maximum possible number of headers for this example. And then somewhere there's a data block having data in here. Okay, this data doesn't tell you a lot. Header blocks for the end of the file, end of the track, end of the head, end of the media. And we just described the whole IBM tape file without knowing about the physical tape structure, but we could show off the whole logical tape structure. So any emulator running an IBM machine could be able to be fed from this data to build up the data structure it needs to emulate the reading of a tape like this. And the important part in here, it's totally readable. It can be tossed around the net without any problem, because text files should go from any machine we know to any other machine we know. Question for this example? Okay. Now, let's just take a different example for a little bit less mainframe geeks. this one. We're coming up with basically the same structure. Okay, when I wrote this example, it was meant as a little test for people if they're following me or if they understand what I'm writing in here. This is a specific home computer, and it's a disk format of this home computer. I don't think we should make a test out of here. It's an Apple II file. It describes a whole Apple II disk. We're just going again. We have a classic data file started. Have one media. Here's, for example, another tag telling us that the emulator or whoever reads it should think this is a GCR encoded media. GCR was the encoding used in the original Apple file floppies. Then we come up, say, okay, there's one head. First head, we have a track in there. The track is the track number 16. Yeah? What we see here, we're at track number 16 and we dropped out the whole first 15 tracks. There was no interesting data. We could compress it out. Track number 16, getting a block, having said this block is data size 256 bytes. It's coded hexadecimal, SED for C decimal, which is, well, more appropriate, I think, and filled with zeros. So this is just an empty block in here. Then we have a block on number 15, filled with this data until here, and then filled with zeros. A block number 17, filled with this data, yeah, and a block on number 15, all on the same track, on track 16, with this data. If you decode this and feed this into an Apple emulator, you will get it perfect directly, bit for bit, just denoting one file length, half a megabyte, one random access file, half a megabyte with one allocated block, which is down here. Like this, you could use this format to get any kind of data structure from any PC to any PC. Now, this might sound now very theoretical. I have implemented this stuff for an Apple II, for a Commodore VIC-20. I've implemented it for a CPM machine, for a KIM, for a BBC is still not working, for a PC, of course, as reading implementations. So what was just going on, it took an original Apple II, put the program under, started it, and hooked up a PC to the serial line, got the Apple to output a file like this, just text stream on the serial line. A program like this could be written in less than an hour in BASIC, because you don't have to check anything. And then the PC was reading this in and storing it. And now I could transfer it over the web, could have it to any kind of emulator or whatever transferred. So that's the basic idea behind that. Of course, once you have this stuff in readable format on a PC, you could use any kind of modern backup on there. Just take it on a CD-ROM. CD-ROM will last for something between 15 and 100 years. Dump it on whatever is actual next time you're changing your computer and so on, or just store it on a web server and have it download from other people. Another feature of the format is you can have, of course, links in there. As we have seen over here, we build up a structure for not only a tape, but also a structure of an IBM computing system. We have one channel defined and one device on the channel defined. Now, instead of having in this file the whole tape in there, we could just have here a media tag and then a link in there pointing to another file having the media. So you can describe the structure of the system, like having 4 disk drives on 2 channels and 2 tape drives on another channel and whatever, a card reader on the next channel in one file and describe the media which are mounted on this device in different files, which opens totally new ways for emulators to describe their environment. Because as far as I know, all emulators for big machines I've seen until now have always used some kind of, well, let's call it individual ways to define the storage of the machines they have or they describe. Yeah?
So this is a data type, right? This is an XML data type.
Yeah. The basic data type is or the file type is CCDD.
Does the data type define a specific way to extend it? Like say you have wheel cogs or something, there's no mechanical.
Excuse me, you're a little bit hard to understand over here.
Do data types define the way that you extend data types? Like say, okay, put any extra tags at the bottom or something like that? Or how do you define that? I mean, if I have something that's not included in your data type, right?
In this basic version, the extension is done by using most as possible generic tags. Yeah. For future versions, we're thinking about using the XML way of extending by using separate namespaces. Just one problem is as soon as we jump onto namespaces and combine different definitions into one by using namespaces, the whole parsing and generating effort suddenly multiplies.
Right.
Yeah. So we'll soon leave the way which a simple computer can generate.
It works real well if you have like a well-defined set of data that works with them, and you know what all possible computers are. So
Yeah.
it's cool. But then if you want to extend it, people don't work with the extension and parse this part out.
Another problem with extension is, of course, if you extend it, the programs who read it must know about the extension and how to handle them. So they get also more complicated. You know, one guy once told me I'm a forerunner on XML. I'm definitely not a forerunner on XML. I'm more of a follower. And at one point, I just stopped following because it got too complicated for me to follow with just my brain. And as soon as this happens to things I'm doing, I'm stopping, I'm staying where I am, because I can only handle structures I understand. I don't know if anybody else can handle 5, 6, 7 namespaces in a file and then parsing these files without any kind of logical definitions, because as soon as you introduce namespace, you can no longer prove the integrity of a file automatically, which is an actual problem in the XML definition.
If you look at supporting Bernoulli boxes, the old Bernoulli cartridges,
Excuse me?
are you familiar with the old Bernoulli box
Yeah.
cartridges? Have you supported those? Looked at those yet?
Well, they look like ordinary disk drives. If they're supported by the computer where you take the data from,
Oh, I
then
didn't
they're
know.
supported. We're not talking about physical data transfer. We're talking about having a computer, being able to read the old data and just transfer it into one of these forms and then give it away on a serial line, on a file, or whatever. Yeah, so whatever media the original computer supports is supported by this structure. Because in a Bernoulli file, the Bernoulli file is mounted on an interface. It has a directory structure, it has a head, or it has 2 heads, depending on the media type. It got tracks, it got sectors, and it breaks down there.
How similar are mechanical computers to this? I'm just kind of curious. If you try to look at any mechanical computer programs?
Well, I don't know about mechanical computers, but just for the sake of it, I'll also wrote a theoretical program to dump SUSE set 1 program tape onto this file format. And I don't know if we can get more basic than this. Okay, the program would have taken up more space than the machine had, but anyway, it could have been done. So, oh yeah, just got showed I got to hurry up.
Does this format describe really the block for floppy drive, for example? block structure, or does it also describe the file structure, the directory structure?
Good that you asked. You can have in here. These two examples were mainly made to show you how to be as physical as possible. Yeah. You could also go in here. Where's the definition? You could also go in here and just have it defined on a file. Where is it? Doesn't matter. You can also go in here and say you have a media. The media consists of files. Just say file 1, file 2, file ID is 1, file ID is 2, file ID is 3, and then just put in the file. The whole structure is just meant as a container to transport the information in a device-independent manner. You can't break it down to physical information like it's used to be for most systems, but you don't have to. Is this your question? Yeah. You had a question? No? Okay. One more question? Okay. Thank you very much for your time.
I'm just going to say a few words about Hans before we move on to the next speaker. If you don't know Hans, he's the organizer of VCF Europe. He first came to VCF2 in 1998, and was beside himself that he hadn't heard about it from VCF1 and couldn't get VCF1. So to make up for the fact that he missed VCF1, he decided that he wanted to start VCF Europe. So Hans is responsible for bringing VCF to Europe. We've done it 3 years in a row now. And I also want to say that Hans is one of my best friends. He's done an incredible amount of, his own personal effort and work into making sure that each VCF goes off at the main VCF here. He's always been there helping. Even though you once in a while hear me yelling at him and cursing at him, it's tough love. Because I love Hans dearly. I want to thank him in front of everybody for all the help he's given to the VCF. Thank you.